Okay, so I apologize for that interruption. I hit the wrong button and I was not going to go back and re-record everything we just did. So, I am going to my unit circle and I'm going to find where the cosine is. So, cosine is 1/2 here at pi over 3 and also here at 5 pi over 3. So I'm going to say pi over 3 and 5 pi over 3 for these answers. Over here, if I add 2 to both sides, cosine equals 2. Now, this can happen that you get something that you don't recognize from your unit circle. In this particular case, this is not going to have an answer for us because cosine is always between 1 and -1. If you look back at your unit circle, the farthest it goes to the right is 1. And so that limits us. Now, had this been something like 0.23, something weird, okay, you can always use your calculator and do the cosine inverse of that. Let's say it was just 3/4. You can use your cosine inverse 3/4 in your calculator or on Desmos and come up with the answer here in a decimal form. And in our case, since we're in radians, you would want to make sure you're in radian mode and record your answer as whatever the decimal is, radians. So again, that is a strange case that can happen. Our case happens to be no solution from this equation, but we did get solutions from this equation, so these are actually the answers for the whole problem. Okay, so you could have a similar problem here. I have some with cosines. The difference is this is not equal to 0, and I need it equal to 0. So I am going to subtract 1 on both sides, and I'm going to add cosine u on both sides, so that I get a 0 over here on the right. On this side, when I structure this, I'm going to put it in descending order of power, so it's kind of in standard form. So basically, get everything on the left-hand side, so it looks like a quadratic. And again, I want to factor into 2 parentheses, and you can use that method, or whatever method you typically use. So this happens to factor to 2 cosine u minus 1 and cosine u plus 1. So again, I have 2 equations. One is 2 cosine u minus 1 and equals 0, and then the other is cosine u plus 1 equals 0. So on the left one, I'm going to add 1, and I get 2 cosine u equals 1, divide by 2, and I get cosine u equals 1/2. So I'm going to go to my unit circle. I'm going to find out what angles give us a cosine of 1/2. If you remember, we actually just did this in example 5, so it is pi over 3 and 5 pi over 3. So I'm not going to work too hard on that one. On this side, I'm going to subtract 1, and I get cosine u equals -1. And then I have to think about where on the unit circle the cosine is -1. So the cosine is -1 right here, which happens to be at pi. So I have this u to be pi. So I actually have 3 answers for this equation. Okay, for example 7, we have sine squared alpha minus sine alpha equals 0. And this sort of looks like the others because it has the sine squared and the sine, which would make it a quadratic look. But this one, you don't have to factor like you would a trinomial. You can actually just take out a GCF. So they both have a sine that you can take out, and that would leave us with sine minus 1. Remember, when you have something and you take it out with that GCF, you have to put that 1 there to hold its place. And this one is actually a lot simpler because you just have sine equals 0, or sine x equals 0, or alpha, excuse me, and sine alpha minus 1 equals 0. This one's already solved. We just have to go to our unit circle and find where sine is 0. So sine is 0 here and over here. So I'm going to use 0 and pi as my answers there. I mean, technically you could use 2 pi, which is, obviously the same place as 0. I'm just going to write 2 of them. So we have x equals 0 and pi. Over here, I'm going to have to add 1. So I have sine alpha equals 1. And then I'm going to my unit circle to find what alpha would be when the sign is 1. So sign is 1 right here, and that is at pi over 2. So alpha would be pi over 2. Okay, example 8 is a similar situation. You do have odd things going on here because you have tangents and cosines, but you still want to get it equal to 0. So I am going to subtract this tangent from both sides. Now, I cannot subtract it from this tangent because it's hooked to the cosine. So I am going to have to write 2 cosine squared tangent minus tangent on the left, and then equals 0 on the right because these two cancel to 0. Alright, so when you look at this, again, you always should check for a GCF when factoring. So both things having a tangent is going to be dealt with the easiest by taking them out as a GCF. So I'm going to take out a tangent. It's going to give me 2 cosine squared x minus 1 equals 0. And then I can write these as 2 equations. So I have tangent x equals 0, and we want to think about on our unit circle where that would happen. And I told you that tangent is the same as like the slope of the line you're thinking about, and the slope of a horizontal line is at 0. So that would happen on the horizontal line on the unit circle. So the tangent would be 0 here, which would be 0, 2 pi, and pi. So again, I'm going to write 0 and pi. So we have x equals 0 and pi. And these kinds of things are going to be helpful if you did take the time to write the tangents down when I suggested that you do that. So 2 cosine x minus 1 is equal to 0 as well. I'm going to add 1 to both sides. So 2 cosine squared is 1. Divide by 2. And I get cosine squared equals 1/2. And to get rid of that square, I am going to square root. So I'm going to cancel the square root and the square. I get cosine equals the positive and negative. And again, square root of 1 is 1. The square root of 2 is square root of 2. This is the same situation that we were in earlier where we rationalized and it became square root 2 over 2. So I'm going to change that. And again, I actually have 2 situations here, the positive version and the negative version. So I'm going to go back to my unit circle and find all the places that my cosine is positive square root 2 over 2 and negative square root 2 over 2. And after looking those up, I get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So number 9 is going to look a little different, but it's still trinomial because you go from a power of 4 to a power of 2 down to a plain number. This can happen when you have anything that goes like that. So if I had this would be a power of 50 and this would be a power of 25 and this would be none, then it's still factorable like you would factor a trinomial with the x. But however you get there, in the front of your parentheses, you will now be putting sine squareds, because half of those will go in the one parenthesis, and the other half will go in the second parenthesis. So that's how those will split up. So these happen to factor because we have the 3 here that we're trying to get a 2 here to a -1 and a positive 3. So if I come over here, this will actually factor again, or you can look at it as a square root version. But this is a difference of perfect squares. So I do have sine x minus 1 and sine x plus 1. This one doesn't change, so I'm just going to keep thinking of it like it is. But I'm going to take each one of these and set them equal to 0. So sine x minus 1 equals 0, sine x plus 1 equals 0, and sine squared x plus 3 equals 0. So over here I'm going to add 1. So I'm going to get sine x equals 1. And if I think about where that is on the unit circle, the sine or y value is 1 at pi over 2. For the second equation, I'm subtracting 1. So I think about where the sine is, or the y value is -1. And that is at 3 pi over 2. So those are easy. and you may even know those without glancing at your unit circle. Over here, I'm going to have to subtract 3. And so I'm going to have sine squared x equals -3. And when I square root both sides, we're going to cancel out over here. And over here, I'm going to get an I square root 3, so positive and negative I square root 3, which is not something that I can plug in my calculator or find on my unit circle. So we're going to just toss that side up to not giving us any answers that are worthwhile. So I'm going to stick with the pi over 2 and the 3 pi over 2 as my answers for this problem. Alright, and this is our last example. Again, I want to get it equal to 0, and I'm going to be factoring. So this is actually all one piece over here on the right. I'm going to subtract cotangent sine squared to the other side. And it will cancel out over here and give me a 0. This side, I can't combine them. I'm just going to write 4 cotangent x minus cotangent x sine squared x equals 0. Hopefully you're noticing at this point this is another GCF problem because both pieces have the cotangent. So I'm going to take that out, and that's going to leave me with 4 minus sine squared x equals 0. This happens to be a difference of perfect squares because 4 is a perfect square and sine squared is a perfect square. So I'm going to have 2 minus sine x and 2 plus sine x. So now I have 3 situations. Cotangent x equals 0, 2 minus sine x equals 0, and 2 plus sine x equals 0. So, to solve this cotangent one, most of us don't know our cotangents. So I want you to think about this in terms of cosine over sine, one of those trig identities we work with. How would we get a 0 from this? It would have to be a 0 on the top, because if you had a 0 on the bottom, then the fraction would be undefined. So I'm basically looking for where cosine is 0 because that would make that whole fraction 0. So if I go back to my unit circle and I look for where cosine is 0, cosine being the x value, it happens at pi over 2. So I'm going to say for this, x is pi over 2. So we move on to the next equation. We want to subtract 2. So I get negative sine x equals negative 2. I'm going to divide by negative 1. The negatives are going to cancel. And the negatives will cancel over here. So I have sine x equals 2. Again, this is one of those situations where if you think about your unit circle, the biggest sine is 1. And or if you think about the graph, the tallest it goes is 1. So sine can't be 2. If it were something between 0 and 1 that weren't on your unit circle, or between negative 1 and 1 that weren't on your unit circle, you could use your calculator and do a sine inverse. But we know this one's not going to give us an answer. In fact, if you plug it in, it's going to give you error. So that's not going to help us out. If you come over here, you'll subtract 2, and you'll basically be in the same situation because, like we said, if you think about the sine graph or the unit circle, sine's always between 1 and negative 1. So this is outside of that range. So these two over here give us nothing, but I did get the one answer over here from the cotangent being equal to 0. So that does give us something for this problem. And that concludes this lesson.